Hi guys, welcome to my YouTube channel, and in this video we are going to discuss acid, bases and indicators. So an acid is a substance with a sour taste, for example orange and lemon juice or even sour milk, while a base is a substance with a bitter taste, for example antacid and also wood ash. Then we have an indicator. An indicator or indicator, they are substances that are used to classify things as either acidic or basic. So an indicator shows a definite color in an acid and a different definite color in a basic solution. So they are okay, I'm going to list down the examples of an acid: hydrochloric acid, sulfuric acid, orange juice, lemon juice. So all of them, they give a similar color when they are placed in a flour extract. Examples of bases, it's like sodium hydroxide, calcium hydroxide, potassium hydroxide, wood ash solution, and also baking powder. So when you use a flour extract to classify whether they are acidic or basic, then they will show a different definite color from that is shown by different acids. Neutral solution are solutions that are neither, or a neutral substance is a substance that is neither acidic nor basic. So examples of such solution is water and also sugar solution. So when you are trying to show whether a substance is acidic or basic using a flour extract, then the results are normally inconsistent. You cannot trust the result because you cannot clearly know which substance it is by looking at colors only. So therefore, there is need for introduction of other substances to show acidity or even basicity or neutrality of a substance. Examples, we have commercial indicators, and we've said that an indicator is a substance that shows a definite color in an acid and a different definite color in a basic solution. Examples of commercial indicators are litmus paper or litmus paper, that is blue and red litmus paper, phenolphthalein indicator, methyl orange indicator. So there is a table that is displayed there in my display that is showing an indicator and its color in an acid solution, its color in a basic solution, and also its color in a neutral solution. So litmus paper is red in an acid, it's blue in a base, and it's purple in a neutral solution. Phenolphthalein indicator, it's colorless in an acid, it shows pink color in a basic solution, and it's colorless in a neutral solution. Methyl orange indicator shows pink color in an acid, yellow color in a base, and in a neutral solution it shows an orange color. So then you are going to discuss the pH scale. So we say that pH is a measure of acidity or alkalinity of a substance. So pH, there is a scale that ranges from 0 up to 14, and it shows whether a solution is acidic, neutral, basic. So the pH scale from 0 to 3 shows strong acids, from 4 to 6 shows weak acids, from 7 it's neutral, and 8 to 10 shows weak acid, and then 12 to 14 it shows strong bases. So at both extreme ends of the pH scale, it shows strong acid 0 and then strong bases at the other end of 14. So there are examples of strong acids that ranges from pH 0 to pH 3. For example, hydrochloric acid, sulfuric acid, and nitric acid. So all of them, their pH ranges from 0 up to 3, or 0 to 4 there. Then weak acids examples are lemon juice, ethanoic acid, basically the citric acids. So their pH value ranges from 4 up to 6. At pH 7 we have neutral solution, for example water, which is a neutral solution. pH 8 to pH 10, then there we have weak bases. And weak bases example is calcium hydroxide, and also sodium hydrogen carbonate is a weak base for that matter. Then strong bases, their pH is from 12 to 14, and an example of a substance which has that strong base, it's wood ash solution, soap, and even sodium hydroxide solution. So okay, now we are going to discuss the reactions of acids and metal. Then you're going to discuss reaction of acid and bases, and then reaction of acid and carbonates. So I've given the examples of acid: hydrochloric acid, sulfuric acid, and nitric acid. So when an acid reacts with a metal examples are sodium metal, calcium metal, potassium metal, etc. So when you put a dilute acid, you put it in a test tube, then you add metal like zinc or magnesium, what you get, you will see effervescence or production of bubbles of a gas. So the gas that is produced through those bubbles, it's a gas that burns with a pop sound. So that is the chemical test for hydrogen gas. So the gas produced when a metal reacts with an acid, it's hydrogen gas. So the general equation for the acid plus metal, it gives you metal salt plus hydrogen gas. A metal, for example, zinc, when you react with an acid like sulfuric acid, you get zinc sulfate, which is a salt, plus hydrogen gas. When you take a metal, for example, potassium, you react it with an acid like hydrochloric acid, you'll get potassium chloride plus hydrogen gas. So what you should know is there are different salts that are produced by different acids. For example, for the chloride, the salts, hydrochloric acid produces a chloride salt, sulfuric acid produces a sulfate salt, nitric acid produces a nitrate salt. So whenever you react a metal with a sulfuric acid, then you expect to get a metal sulfate plus hydrogen gas simply. So when you take zinc metal and then you add hydrochloric acid, the salt for hydrochloric acid is a chloride. That's why you will get zinc chloride plus hydrogen gas. Magnesium and aluminium metal, they react more vigorously with acids than zinc. So also they produce metal salt plus hydrogen gas. So magnesium plus hydrochloric acid, it gives you magnesium chloride plus hydrogen gas. Aluminium plus hydrochloric acid, it gives you aluminium chloride because of the salt plus hydrogen gas. So therefore an acid is a compound that reacts with metal to form salt and hydrogen gas as the neutral product. So the general equation is metal plus an acid to give you metal salt plus hydrogen gas. So very reactive metals, for example, potassium, sodium, and calcium, which react violently even with water, it is not advisable to react them with acid because their reaction will be very violent. So we have a metal like calcium. When it reacts with dilute sulfuric acid, then it's supposed to form a calcium sulfate. So calcium sulfate, the reaction starts and then slows down and eventually stops due to formation of an insoluble coat of calcium sulfate that prevents further reaction. Lead, it's also another metal. It reacts very slowly with both hydrochloric acid and sulfuric acid, and then the reaction will also stop due to formation of insoluble coating of lead chloride and lead sulfate that prevents further reaction. Copper doesn't react with either dilute acid, which is dilute hydrochloric acid, or dilute sulfuric acid. So that table below summarizes the salt, the acid and the metal, and then the name of the salt that is formed. I've said hydrochloric acid forms a chloride, sulfuric acid forms a sulfate, nitric acid forms a nitrate. If it's a carbonic acid, it will form a carbonate, and then phosphoric acid it will form a phosphate. So if you react hydrochloric acid with magnesium metal, it's going to give you magnesium chloride. That is the salt, now plus hydrogen gas. Sulfuric acid plus magnesium, it will give you magnesium sulfate plus plus hydrogen gas. Nitric acid plus magnesium, it will give you magnesium nitrate plus hydrogen gas. Carbonic acid, when you react with magnesium, it will give you magnesium carbonate plus hydrogen gas, and so on. Now, reaction of acids with carbonates and hydrogen carbonates. So an experiment is done. You add a carbonate, for example sodium carbonate, into a test tube that contains about maybe 5 centimeters cubed of hydrochloric acid, and then you observe what happens. So when an acid is added to a carbonate or a hydrogen carbonate, then effervescence is seen. Effervescence, it's production of bubbles of a gas, and therefore a colorless gas is produced. So that colorless gas that is produced is carbon 4 oxide. And how do you confirm the gas produced is carbon 4 oxide? So you bubble that gas through calcium hydroxide solution, or else called lime water, and a white precipitate will be formed. So that is the chemical test for carbon 4 oxide. So acid reacts with carbonates and also hydrogen carbonates to form 3 substances, that is a salt, water, and carbon 4 oxide, which is the colorless gas. So if you take a carbonate, for example sodium carbonate, you react with hydrochloric acid, then the salt form will be sodium chloride, because of hydrochloric acid, salt is chloride, plus water plus carbon 4 oxide. If you take calcium carbonate plus nitric acid, the salt for nitric acid is a nitrate, so it will be calcium nitrate plus water plus carbon 4 oxide. If you take copper 2 carbonate plus sulfuric acid, the salt is a sulfate, so it will be copper 2 sulfate plus water plus carbon 4 oxide. So if you react sodium hydrogen carbonate, even if the name is hydrogen carbonate, still 3 products will be formed. That will be sodium hydrogen carbonate plus hydrochloric acid. It will give you sodium chloride plus water plus carbon 4 oxide. So 3 products are formed when an acid reacts with a carbonate. So generally, acid plus a carbonate gives you salt, water, and carbon 4 oxide as the only products. So the reaction between sulfuric acid and calcium carbonate starts and then stops after a short while because of formation of an insoluble coating of calcium carbonate that stops further reaction. Finally, let's look at reaction of an acid and a base. So the reaction of an acid and a base forms a neutral product. Generally it's said to be a neutralization reaction. So phenolphthalein indicator is normally used to determine the end of the reaction or the end point. So it is used to determine the quantity of the acid that is needed to react with a certain quantity of a base, for example, sodium hydroxide solution. So the color of phenolphthalein indicator is pink in a basic solution. So when a pink color is displayed, now you know that the reaction has completely taken place. So acid react with base to form salt and water as the only neutral products, and therefore the reaction between an acid and a base, it's a neutralization reaction. So if you take an example of a base which is sodium hydroxide, so bases examples are metal hydroxides and metal oxide. So sodium oxide, potassium oxide, calcium hydroxides, potassium hydroxide. So basically metal oxide and metal hydroxide, those are the bases. So when you take an example of sodium hydroxide, you react with dilute acid. For example, that is hydrochloric acid. Therefore you are going to get sodium chloride plus water. So the products are salt and water as the only neutral products. So zinc oxide, which is a base, you react it with hydrochloric acid, which is an acid. It will give you zinc chloride plus water. So zinc chloride is the salt and then water. Magnesium oxide, which is a base, you react it with an acid like nitric acid, of which I said the salt for nitric acid is a nitrate. It will give you magnesium nitrate plus water. Lead 2 oxide, it's a base. When you react it with nitric acid, you will get lead nitrate plus water as the only neutral product. So therefore we define a base as a substance that reacts with an acid to form salt and water as the only neutral products. You can also define an acid as a substance that reacts with a base to form salt and water as the only neutral products. So there are differences in properties of acids and bases, and for example, an acid has a sour taste where a base has a bitter taste. That's one difference. And acids have pH that is below 7, while bases have pH that is above 7. An acid changes litmus paper from blue to red, while a base changes litmus paper from red to blue. Bases changes phenolphthalein indicator to colorless, where acids changes phenolphthalein indicator to colorless, while bases changes phenolphthalein indicator to pink. Acid changes methyl orange to pink, while bases changes phenolphthalein indicator to pink. Acids react with the base to form salt and water as the only neutral product. That is a similarity between the acid and a base. So effects of an acids on substances. So when industries emit gases, that is for example sulfur dioxide to the environment, they lead to environmental pollution. They can also lead to acid rain that later on destroys the plants, and also it damages metallic or substances made of iron in a process called corrosion. For example, causing rusting on the iron sheets of houses and other metallic surfaces. So there are revision questions. So they are basically about what we've covered in the topic. You can try them out and then we'll cover them in the next video. See you. Thank you for watching.